Hey, Econ 1B students. Today I wanted to take some time and go over some of those final review problems that are on the extra credit homework assignment. So if you're on Canvas and you're working your way through those problems, I want to make sure you have a sense of how to answer them before we start the final. So today I'm going to, in this quick video, go through problems 3 and 4. So problems 1 and 2 just ask you about efficiency wages and the difference between monopolistic competition and perfect competition. Problems 3 and 4 look at, well, we're going to look at them. One looks at the value marginal product of capital, looking at milking robots, and the other one looks at deriving the average total cost curve, average variable cost curve, and marginal cost curve of a firm. So let's get started. So problem 3, if you aren't looking at it, says that Smiling Cow Dairy can sell milk at $5 a gallon and can rent robots to milk the cows at a rental price of $200 a day. The production function for Smiling Cow is shown in the table below. So the first thing you want to do is fill in the marginal product of labor and the value marginal product of labor, and then determine how many robots the firm should rent. So we've got the number of robots here, the gallons of milk produced, and then we're going to have the marginal product and the value marginal product. And in this case, it calls the problem calls it labor explicitly, but we could think about this as also being capital, right? We could say, oh, well, maybe robots aren't labor, they're capital, but the outcome is the same, right? It doesn't matter whether we're talking about workers that have a wage or capital that has a rental price or land that has a rental price. We're going to treat everything the same. We're going to be comparing the cost of that factor of production, that input, to the value marginal product of it. And we want to remember that the price associated with this product, that now we're talking about gallons of milk, it's going to be $5 for a gallon of milk. So let's go through and just fill this table in real quick. So we have 0 robots, 1 robot, 2 robots, 3 robots, 4 robots, 5 robots, 6 robots. 0 robots produces no milk. 1 robot produces 60 gallons. The second robot gets us up to a total of 100. The third robot gets us to a total of 135. The fourth up to 155. The fifth up to 170. And the sixth gets us up to 180 gallons of milk. We then want to look at the marginal product of each robot. So the first robot takes us from 0 to 60. So that's going to give us a marginal product of an additional 60 gallons of milk. The next robot takes us from 60 to 100. That means that the marginal product of that second robot is going to be the difference, right? 40 gallons of milk. The next robot takes us from 100 to 135. That gives us a marginal product of 35 gallons of milk. Then we go from 135 to 155. So that means that the marginal product of that fourth robot is only 20 gallons of milk. Then from 55 to 70, that's going to be another 15 gallons. And then from 170 to 180 is a marginal product of 10 gallons of milk. So far, so good? To get the value marginal product of labor, we just want to multiply that marginal product by the cost, the price, or the value, the market value of what's being produced. So if gallons of milk are $5 each, 60 gallons of milk is going to give us a value marginal product of 60 times 5, or 300. The value marginal product of the second robot is 40 times 5, or $200. The value marginal product of the third robot is 35 gallons times $5 a gallon, or $175. And then the fourth robot gives us a marginal product of 20 gallons of milk at $5 a gallon, for a value marginal product of $100. Then the fifth robot gives us 15 gallons of milk, $5 each. That's $75 in value marginal product. And then the last robot only gives us 10 gallons of milk on the margin, which is each worth $5 for a value marginal product of $50. Cool? Makes sense? the next thing we want to do is we want to say, okay, well, given that information and given that we can rent a robot for $200, how many robots, oh, you can't see that one. So if we rent a robot for $200, how many robots will we want to rent? Let me see if I can get the glare out of there for you guys a little bit. Oh, here. I remember how to do this. So if renting a robot is $200, we can go through and look at this marginally, right? We can say, okay, would we rent the first robot? Yes, it costs us $200, but it makes us $300 in terms of revenue. The second robot gives us $200 of revenue and costs us $200. That's where we're going to stop. Remember, firms are going to hire factors of production up until the point where the value marginal product is equal to the rental price or the rental rate or the wage or whatever. So if we're looking at the value marginal product of land, we're going to rent land up to the point where the rental rate of that land is equal to the value marginal product of land. If we're looking at labor, we're going to hire workers up to the point where the wage is equal to the value marginal product of labor. So far, so good? Makes sense? If I wanted to ask you guys to graph it, you could go through and do that graphically. You'd say, okay, well, here we go. Just kind of squeeze it in here. We'd look at the quantity of, let's say, robots we're going to hire and the rent associated with them. And we'd say, okay, well, the first robot gives us a value marginal product of $300. The second robot gives us $200. Let's space these out a little bit better. And I can plot that curve, right? So the first robot gives us $300. Second robot gets us down to $200. It's a pretty steep drop off. Third robot, $175. Fourth robot, $100. Fifth robot, $75. And then the sixth robot is $50. It's going to look kind of like that. And that would be the value marginal product curve, or the demand curve for these robots. And then the rental rate is going to tell us how many we're going to hire. So we put that rental rate in at $200. That tells us that we're going to be hiring 2 milking robots. Make sense? Hopefully, a little bit. The next part is problem 4. So problem 4 says that a firm faces the below variable costs and a fixed cost of $8 per unit. And we want to find the marginal total cost, average total cost, average variable cost. And then we want to talk about what the firm would do in a perfect competition scenario in the short run and the long run. So let's take a look at that. So I've got here the chart from the page, or from the problem. So we've got our quantity of output, we've got our variable costs, and then to get our total cost, we just add our fixed cost, which is $8. And you can tell because at a quantity of 0, we're still paying $8 in fixed costs and 0 in variable costs. So we start by just going in and adding the variable costs to $8 to get our total cost. So I'll go ahead and do that. So 8 plus 1 is $9. 8 plus 6 is 14. 8 plus 15 is 23. 8 plus 28 is 36. And 8 plus 45 is 53. So far, so good. Remember, total cost is just fixed cost plus variable costs. Then average variable cost, that's going to be our variable cost divided by our quantity. So we start out with a variable cost of 1 divided by 1, which gives us the average variable cost of $1. Then we have 6 divided by 2, which is going to give us an average variable cost of 3. 15 divided by 3 gives us an average variable cost of 5. 28 divided by 4 gives us an average variable cost of 7. And then 45 divided by 5 gives us an average variable cost of 9. Same thing for average total cost. We take total cost here and divide it by quantity here. So let's do it in another color just to keep things fun, because we can. If not now, then when. So 9 divided by 1 gives us average total cost of 9. We also have average total cost of 14 divided by 2, or 7. 23 divided by 3 is going to give us an average total cost of 7.66, or 7.67. 28 divided by 4 gives us an average total cost of $9. And then 53 divided by 5 gives us an average total cost of $10.6. And then marginal cost. Remember that marginal cost is just the change in cost as we move from producing one unit to another. So if we want to look at producing 0 units to producing 1 unit, we're going to see total cost go up by $1, right? That's that additional variable cost associated with producing that next unit. So our marginal cost of our first unit is $1. Our second unit, we go from a total cost of $9 to 14. So that's going to give us a marginal cost, an additional cost of $5. Then we go from producing it costing $14 to produce 2 units to it costing $23 to produce 3 units. So that's going to give us a marginal cost of $9. Then 13, and then 17. So far, so good? Make sense, mostly? All right. So the next thing we want to do is graph marginal cost, average total cost, and average variable cost for this firm. So let's take it back to the big whiteboard and get that graph for you guys. So we've got our marginal cost, average total cost, and average variable cost, which range from 1 to the highest of $17 for the marginal cost of that last unit. So I'm going to go up here and put that be $20. And that's going to be $10. And then that'll be 5 and 15. And that should get us started. Then I'm going to go from 0 to 1, 2, 3, 4, and 5. All right. So we can start out with our average variable cost curve, where the variable cost of 1 is $1. The average variable cost of the second unit is $3. The third unit, it's $5. The fourth unit, it's $7. And then the fifth unit, it's $9. That's going to be kind of like that. Average total cost is going to, and we can imagine, usually average variable cost is U-shaped. We can sort of imagine that there might have been some other higher end if we could have reduced production or something like that. But I'm not going to worry about that shape. Don't worry about that shape too much. It has the relationship we expect, which is that the variable costs are rising on average. Honey, please don't make a mess. No, sorry. August, please don't pour water on my bed. So now that we've got our average variable cost curve graph, we want to go ahead and graph our average total cost curve. The total cost is going to start out with an average of $9 right here, right there. And then it's going to go down to 7, about there, and then down a little bit, up a little bit higher to 7.7 right there, barely perceptible. back up to 9. And then it's going to go up to 10.6. Cool. Last but definitely not least, one of our favorite curves ever, the marginal cost curve comes in. Marginal cost is going to start out here at 1. Then we're going to go up to $5 for the second unit. Then it's going to be $9 for the third unit. Right there. And it's going to go up to $13 over here. It's going to be right there. And then the fifth unit is going to have a marginal cost of $17. That's going to pop us all the way up right here. So it's going to look kind of like that. Cool? Kind of works? Kind of makes sense? The next part of the problem says, now that we've got this graphed, assume this firm is perfectly competitive and faces a price of $13. At what level would the firm produce? So remember that firms are going to produce at marginal revenue equal to marginal cost, right? Every firm produces at marginal revenue equal to marginal cost. If this firm is in perfect competition, then the price is the marginal revenue. So if our price is, I think it said $13, then that's going to be our marginal revenue. So we want to go ahead and add in a marginal revenue curve that reflects that. I'm going to do that with this one. And that's going to be about here, right? If we want to know how many units this firm is going to produce, we can either go back to our table and see where they would produce at marginal revenue equal to marginal cost, knowing that marginal revenue is now $13, which we can see right here. $13 means we would produce 4 units. Or we can look at our graph and say, okay, when marginal revenue is equal to marginal cost, if we bring that down, that firm is going to produce 4 units, right? Sound good? So far, so good? Rings a bell, right? There we go. So that is part C. Part D asks, what would they produce in the short run, and what would they produce in the, would they produce in the short run, would they produce in the long run? And now we're asking about the shutdown rule in the short run, and then exit and entry in the long run. So in the short run, firms make the decision about whether or not to produce based on average variable costs. If marginal revenue is greater than average variable costs, they're going to produce. And we're going to be looking at this production point here to make that choice. And you can see here's average variable cost. Here's marginal revenue. This firm has, you can also look at it at the table, right? At a quantity of 4, the firm faces average variable costs of $7 and gets paid marginal revenue of $13. So they would definitely stay in business in the short run, and in the short run they would produce those 4 units. In the long run, firms have to consider their fixed costs in addition to their variable costs. So we want to compare marginal revenue to average total cost. And we can do that on the graph or in the table, but at a quantity of 4 units, average total cost is going to be $9, and that's still below that marginal revenue, below that price. And you can see that right here. And that basically means that this firm is going to be earning economic profit. So they will definitely stay in business. They will definitely produce those 4 units. And the reality is the long run equilibrium for this firm, for this industry, is going to be that new firms enter the market. New firms are going to see these economic profits being generated, right? Let's see. Yeah. Because this firm is going to be earning $9. They're going to cost them $9 to make 4 units. They're going to make $13. So that means they're going to have a profit of 13 minus 9 times 4, or 4 times 4. So that's going to induce other firms to enter the market. The more firms enter the market, that's going to shift the supply curve out, lowering the price. You don't have to take my word for it. We could draw it right here. So if we have the market for this good with some demand and some supply in equilibrium, remember that one of our non-price determinants of supply is number of firms. As more firms enter the market, we're going to see the supply curve shift out as more units are being able to be supplied to the marketplace. That's going to lower price, and price is going to continue to go down until we get to our long run equilibrium, which is where marginal revenue is equal to marginal cost and average total cost. That's not the problem. That's just good to know, and that's just a good refresher. So that's how you solve number 3 and number 4 in the final review problems. Let me know what other questions you have, and I will see you guys next time.